Hey math kids, today we're going to talk about integration by parts, and it really is as simple as just following this formula. Okay, so we have this integral, and so we're just going to pull out u and v prime. So u is x, v prime is e to the negative x. And to get to u prime, we just take the derivative. To get to v, we take the antiderivative. So we rewrite this and then divide by the derivative of the inside. Then we just plug it into this formula. So we say u v minus the integral of u prime times v. Do some simplification. This negative can come out here. Alright, and then we will actually take the integral, finally. That's what that is. We still have this thing. And then, that is the answer. Your book takes it one step further. They factor out a negative e to the negative x, which would leave x plus 1 plus c. And then they also do a check where they take the derivative of this and verify that they end with this. Okay. Now the next one is going to be x cosine x. So once again, we find our u, our v prime. So right there, u prime is 1 again. If we take the antiderivative of cosine, we get sine. And then we just plug it into this portion. So we get u times v, and then u prime times v, oh whoops, I wrote v prime, sine x dx. Okay, simplify that. Now we take the antiderivative. The antiderivative of sine is negative cosine plus c. We have two negatives there. So just combine those two negatives to a positive. And once again, you can take the derivative of that to check that it really does come back to that. Alright, get rid of this, just so I can keep that formula on the board. Okay, this time we have e to the x sine x dx. Okay, so we pull out our u, pull out our v prime, u prime, v. So our u is e to the x. If we take the derivative of that, it's e to the x. Our v prime is sine x. If we take the antiderivative of that, we get negative cosine x. Alright, so now I'm going to plug it into this side. So I get e to the x, negative cosine x, and then u prime is e to the x, and then v is negative cosine x. Okay, simplifying this a little bit, we get negative e to the x, cosine x. I'm going to pull this negative out with this one, make a positive. And then we just get e to the x, cosine x, dx. Now, I think what I'm going to do, whoops, not that. I'm going to zoom out a little bit. And remember that everything that's in yellow is equal to this. Okay. That'll be important later. Now I'm going to do integration by parts for this again. So u is e to the x, v prime is cosine x, u prime is e to the x, and v, if we take the antiderivative of that, we get sine x. Okay, so just for this part, let's change colors. Just for this part, we're going to plug it into this. So e to the x times sine x minus u prime, which is e to the x, and then just v sine x dx. Okay, so that's simplified. Now I'm just going to write something that makes sense. So I'm going to rewrite this, e to the x sine x dx equals, so remember it equals this plus this, because that just equals that. So negative e to the x cosine x plus e to the x sine x minus the integral of e to the x sine x dx. Now notice that this and this are the same, so I'm going to add this onto this side. Alright, so we have two of those, so we're going to have 2 integral e to the x sine x dx is equal to negative e to the x cosine x plus e to the x sine x, because these cancel. Alright, so we just need to know what this is, and we have 2 of those, so we can just divide everything by 2. And so e to the x, or, you know, this thing, is just negative 1/2 times, or here, let's do it this way. So let's pull out an e to the x, and then also we're dividing that by 2, and also it's negative. Actually, let's write it as negative 1/2. So negative 1/2 e to the x, and then we're going to be left with sine x and negative. Let's see. No, let's not take that negative. Take it back. Sorry. So we're just going to pull out e to the x. Sorry. 1/2 e to the x, and then our sine is positive, cosine is negative, and since all this was like antiderivative, there's definitely a plus c at the end of this, which I should have been adding that in multiple places along the way. I forgot to, but in the end, this is what we have, and that is our answer. Once again, you could take the derivative of this to make sure that it does equal this thing. If you need additional help, please come to Math Lab. Until then, calculator.